Well, two first things. Number one, tomorrow is election day. So if you happen to be 18 by tomorrow, you can still vote same day. Okay? If you have a friend who's a senior and is 18 and they haven't registered to vote, they can register to vote same day, and you can go and you can vote, and you should. Okay? If you are not eligible to vote, talk to your parents, talk to your grandparents, talk to your aunts and uncles, and make sure they vote, friends. I feel very strongly about this. Literally the reason, how come?
Yeah.
Because, well, so short answer, you should vote.
Right.
Long answer, I can't tell you my politics, but I can tell you that I feel that some decisions and paths that we have been set on lately are not what I believe is good for kids, good for people in general in this nation.
Amen.
Yeah, I mean, we could talk about it more in depth also, but just in general, I feel like the voice of those that need to be heard is not being heard. Yeah?
Are you not allowed to share your political opinion?
I am not, there's a fine line. And I don't want to cross any line because I don't want anybody to say that I'm telling you that you should vote a certain way. Does that make sense? But I can absolutely tell you that you should vote. And I can discuss ideas with you. I just can't tell you what my opinions are. Does that make sense? Because there are tricky things, not so much for me, because I think you guys know me and trust me and understand that, like, if I found out that you had political views that were different from mine, it wouldn't affect the way that I graded you or something like that. But that it's a power structure issue, right? That if somebody feels pressured to believe something or do something because of the person that has power over them, then it sets up really yucky stuff. So yeah.
Like one of my old 8th grade teachers I'm friends with on Facebook, and
well, that's a whole different issue.
Okay. Yeah,
if you're friends with them on Facebook, well, that's a friendship. Yeah. So like I'm not allowed to be Facebook friends with you all because I'm your teacher.
What about like next year?
But my rule is once you graduate from high school, then I'll be your friend. Because I don't want it to be like, you know what I mean? Like I don't want you to happen to, I don't know, it's just weird.
Yeah.
That's been my personal rule is
It's done.
once you graduate, then I'll be friends.
It's down.
It's done. One of our 8th grade teachers has like an Instagram, and she follows like all of her students, and I think that's
Well, that's education.
Yeah, I mean, it depends on what it is.
I think yesterday she put out a poll saying I to see how much
Yeah.
rate some people have.
Did you see that?
So, okay. All right. So, number one is to vote. Make sure that you remind people that are around you to vote. Please, 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 please. I mean, I can tell you that the reason that I've been so behind on things is that I go door knocking every weekend, and I have for the last 2 months, which is why I haven't had as much time to work. So I feel, knocking on people's doors saying, hey, want to make sure that you're going to vote on Tuesday.
My parents just don't answer those.
I know, because I probably knocked on your door. I'm just saying. All right. Second little piece of not physics related stuff. I spent the other half of my weekend this weekend hanging out with a bunch of physics teachers and physics professors. The American Association of Physics Teachers Iowa section. We have like a little meeting once a year. And I had really great conversations with professors from St. Ambrose, which is in Davenport, from Loris, which is in Dubuque, and Clark in Dubuque, and from Dort and Morningside that are up in northwest Iowa. And found out really great stuff. There's lots of money there, friends, for people that are interested in going into STEM fields. In fact, my friend from Loris, they just got a National Science Foundation. If you guys have ever heard of the National Science Foundation, they're like, they have money that they give grants to for research and also for education. My friend from Loris just got a grant. It's for people that are going into STEM fields. This is a grant just for this year so far. But if you're a senior and if you're interested in looking into Loris, beautiful campus, that's where I was this weekend. They don't have a physics major, but they do have biochemistry, biology, biological research, chemistry, computer science, data science, engineering, math, and neuroscience. If any of those things sound maybe at all interesting to you, I've got information about getting scholarships up to like $7,000 per year, paid for directly, no strings attached, anything like that. So If you're at all interested, I'll leave these up here so you can grab one or you can ask me questions. But again, and I said this before to you guys, but I want to make sure that you think about college and make good decisions for you, right? Don't just make a decision because it's close. Don't just make a decision because your friend's going there. That's my spiel. Questions before we move on to physics? Okay. Homework questions. We did 3 problems for homework this weekend. Page 132, 3 and 4, and 134, number 1. They were, I think, pretty much just calculation-y problems. I don't think there were too many thinkers. But question?
Can you go over how to show work and how we should, like, kind of...
Absolutely.
take this?
Yeah, do you have a preference of which one I do?
Can we just do number 3 first?
Sure thing. So page 132, number 3. Yep. So 132, number 3. Absolutely. Good question. So let's take a look at number 3. It says a car has a mass of 1.5 times 10 to the third kilograms. If the force acting on the car is 6.75 times 10 to the third newtons to the east, what is the car's acceleration? So first thing I'm going to do, I don't really need to draw a picture. This isn't really it's not really a picture-based question, this specific one. We'll get to those. So we're just going to write down our givens. And it looks like the first thing that they told me was its mass. So 1.3 times 10 to the, 1.5 times 10 to the third kilograms. And it says a force acting on the car is 6.75 times 10 to the third newtons. To the east.
Can you call that net?
That is the net force, yeah. Okay. Yeah. Because, and it doesn't really say that, does it? It really doesn't. But I think it's implying that that's the only other force besides gravity and a normal force pushing up. So if you were going to draw a picture, I would not force you on a question like this to draw a picture, but, spoiler alert, there won't be a problem quite like this on your test because I'm not going to give you something quite this easy. But if you were going to draw a picture for this one, which we totally could, here's my car. And I've got some forces acting on it, right? So the ground is there. So I've got the earth pulling down. And I've got the ground pushing up. And then I've got some sort of force, some sort of applied force. So we'll call that the force acting, the force of I don't know, it doesn't actually say, which is super annoying here. Say the force of the motor on the car. That's an applied force. Okay. So I think what they're really implying is that this is the only force that's the net force because these two are going to be equal in magnitude. So add up to 0. So far, so good. Are we okay? Okay. So then it wants to know the acceleration. Now we should, just for clarity and completeness, take a look at your orange equation sheet because this is the thing that you get to have on your tests and so the thing that you should be referring to on your homework as well. Okay, we're done with that first box. Woohoo! Moving on to the second one. That very first equation, it's got some scary looking stuff at the beginning. I'm going to skip the scary looking stuff and I'm just going to write down, this is the equation that I want. F net, maybe, equals mass times acceleration. Okay? That's all you really need. Does that make sense? That's what you really need. This is not the way I showed it to you. I like it as A equals F over M, but I think I wrote it this way because this is how it is in your book. And this is the nice way, but these are the exact same thing. Are you with me there? Okay, divide by M on both sides from here and get here. Multiply by M on both sides to get there from there. And so then we got to plug it in. So we're going to say, all right, acceleration is equal to 6. Oh my gosh, what is going on? 6.75 times 10 to the third newtons divided by 1.50 times 10 to the third kilograms. I think those 10 to the thirds are going to go away. What do you think? Probably, Miss Probably. It's what, like 4.5-ish? meters per second squared. I'm not going to be a big stickler on the direction, but if you were going to have a really complete answer, you'd say that the acceleration was to the east.
So do we just know what meters per second squared, or is it really like
You can write newtons per kilogram.
newtons per kilogram?
Newtons per kilogram is the same as meters per second squared. Do you want me to show you why?
Yeah.
Yeah. So, yeah, let's look at it. So, a Newton is a mass times an acceleration is a kilogram meter per second squared. That's what it's defined as. So instead of writing 6.75 times 10 to the third newtons, if you're like off the deep end, like I'm pretty close to the edge on the disliking Isaac Newton thing, but if you go off the deep end, then you could write 6.75 times 10 to the third kilogram meters per second squared. And that would be a legitimate answer, right? So if you divide by kilograms on both sides,
So you would accept both answers?
both sets of units, you mean?
Yeah.
Sure thing. Yeah, you know, because we've been doing acceleration for a while that it's that it's meters per second squared. But if you want to write newtons per kilogram, that's not wrong. I'm not gonna count something wrong that's right? That would be mean. Yeah. But does that address the question you wanted to know?
Yeah.
So just follow this. Yep. Follow that, just like always. Yep. Tomorrow or the next day, we will do some more problem solving so you can really see in a bigger context what this is going to look like with the picture and all of that too. But for that, you're good with that.
Thank you.
You're welcome. Anytime. My pleasure. All right. Are we okay with the others? Do you want to know the answers? Number 3 was 4.5 meters per second squared. Question 4, the answer was 2.1 kilograms. And then question 1 on the next page was, part A was 12 newtons and part B was 3 meters per second squared. Emma, did you have a question? Or was I dreaming? Okay, just want to make sure. All right. I've got one quick ranking task for you guys to look at, and then we're going to do a lab today. A lab, I know, right? Good stuff. All right, take a look. Forces on blocks in a smooth surface. It says, 2 forces act on a block that is initially at rest on a frictionless surface. The question asks you to rank the speed of the block after 3 seconds. Question?
Does this matter in what direction it's going?
So it says speed, and speed does not have a direction, so positive or negative doesn't matter. Yeah.
Yep.
Good question. Good question.
Yes.
And then D is just a bigger force, and then A has 4.
All right, I didn't get boards out today because we only have just one of these. So I want you to come up with an answer. I want you to commit to it, write it down, so that we can talk about it, because I'm going to ask for some answers. You guys ready? Got an answer?
Yeah.
Got an answer? Got an answer? Yeah? All right. Can I have some answers? Who's got one? Go.
B equals C greater than A greater than D.
B equals C greater than A.
I'm not saying they're right. I'm just asking.
We put 0 because we believe that there was no acceleration.
Okay. What'd you guys say? This one? All right. So no. I want to know. So tell me about the 0 thing.
We were thinking
Yeah.
like since it's frictionless and like
Yeah.
there's no acceleration, there can't really be a speed thing, so it's just gonna be 0 because so like that's what we were thinking. Yeah.
Sure. So I think I want to see if I'm understanding what you're saying. So you're saying, okay, so there's a box on a surface. There's no friction. So
Like I don't know, I don't know how to word it.
No.
Does friction, I think our question is like, friction would affect the speed, right? If there's no friction, then would it be able to go anywhere? Like, it's just
Oh,
like,
okay.
So, yeah, like it's just.
Without friction, there's nowhere for it to go?
Yeah.
Kind of a thing? Gotcha. Okay. So that is right. Yeah, that if there's no friction and it's just like, and there's nothing acting, that it's not going to go anywhere. And if there is friction, then that's going to affect the answers. That is totally true. Yeah. Yeah. So the other little piece of it though is that there are 2 other forces acting. So like maybe you can imagine this air hockey. Yeah. Do we know air hockey? With like the little puck that just kind of hovers there, right? And it just sits there. So that's kind of what we're talking about. So there's like, we could talk about like like a cushion of air underneath this little box. Like so. But then maybe it's a small table, and then maybe Mira's got a string that she's pulling on one end here. Excuse me. And then Malik's got a string that he's pulling on this end here. Does that make sense? Yeah. So even though there's no friction, there are still forces acting on that thing. Does that make sense? And depending on who's pulling harder, that may still affect the motion of the box or the object. Does that seem okay?
Yeah.
So in that case, like in D, so if Mira's pulling this way and Malik's pulling this way, who's pulling harder? They're the same. So the net force here is what?
0.
0. So in this case, if F net is 0, then the acceleration, which we know is F net over M, if F net is 0, then A's got to be 0, right? So acceleration is 0 in this case. But in C, who wins? F1 or F2? F2's winning, right? F2's pulling harder. What's the net force in this case? 2N to the left, right? So F net equals 2. It happens to be to the left, but I don't really care about direction. So my A is going to be 2 over 2, which is just 1 meter per second squared. And then in B, what's the difference between B and C?
Direction.
Just the direction, right? So F net is still 2. It's just 2 in this direction this time as opposed to this direction. So the acceleration is still 1 meter per second squared because the mass is also still the same. And in A and B are almost the same too, right? What's the net force in A? 2 newtons. So then A should be equal to B and C, right? Oh, mass is different. Is that making sense? So you've got 2 newtons of force, but now the mass is twice as big. So instead of 2 divided by 2, it's 2 divided by 4. So you've got an acceleration of 1/2. Is that okay? Is that the answer? Did I figure out the answers? What's the question asked, Ben?
Rate the speed of the block after 3 seconds.
Yeah, it doesn't say anything about acceleration. It says rank the speed after 3 seconds. Does that mean that I need to go ahead and calculate all of the accelerations? Ryan, you're kind of shaking your head. Why do you say no?
Well, if it's frictionless, I'm guessing it's just going to stay the same.
What's going to stay the same?
The speed.
The speed? Do you guys agree? Is the speed going to stay the same?
The acceleration.
Say it again.
The acceleration. Stay the same.
The acceleration will stay the same.
The speed.
The speed is going to change, isn't it? Because this one is going up 1 meter per second every second for 3 seconds. So if it starts initially at rest, let's do it because we can. And because it's going to matter for the next thing we do. So I just want to get this in our heads. Okay. The acceleration is equal to, isn't it like VF minus VI over T or something like that? So I can solve for the final velocity. Oh yeah, that's 0. So VF is really just equal to A times T. So it's the acceleration times 3. So 1 times 3 is 3, and 1 times 3 is 3, and half times 3 is 1.5, right? So the ranks of the accelerations are all the same as the ranks of the speeds. But if you had a question like this on a test, you would need to make sure that you don't just stop the conversation here. You with me there? Because the question doesn't ask about acceleration. The question actually asks about the speed. Is that okay? Okay. Go.
So what was that?
I don't know. What is the answer? Which one's the biggest? Biggest acceleration is going to be biggest speed, so that would be B and C.
I thought you pointed cannot determine. I was confused.
Oh, no, I'm just flailing my arms. So B and C are the same. A is a little bit smaller, and D is a little bit smaller yet. So B is equal to C is greater than A is greater than B. Hello? All right. It is time to lab. So I've done this lab a lot of times, but I reconfigure it every time I do it. So now you have a new reconfigured lab, because that's how I roll. So I'm going to end up giving you 2 half sheets of paper. Because I think it'll be better this way than 1 full sheet of paper. You're welcome. It's the equivalent amount of paper. All right. So, ladies and gentlemen, let me have your attention up here so that I can kind of walk you through what's going to happen. And then I'm going to let you go and get started. So in just a minute, I will take you over to show you what the lab setup looks like. But this picture right here is a really nice description of it. You're going to have a little cart, and that cart's going to roll along a track. It's hooked to a string on a pulley that goes down, 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 okay? So I just want to think this through. In fact, I don't want to just think it through. I want to actually draw a picture. So on that picture, right now, draw a Freebody diagram. Tell me what forces are acting. It's frictionless. Tell me what forces are acting on this cart right here. Describe real quick, and you can just draw them right on your picture on your lab. What forces are acting? Go ahead and do that. Yeah. We haven't really talked about all this. Get to introduce some new content here. It's awesome. Are you so excited, Josie?
Did you call it a cart?
Cart. Yes, I called it a cart.
So
Yes, of course I'm excited.
trying to be.
My enthusiasm is just like overflowing.
It's a Monday.
It's totally a Monday, which is why I'm putting it all on. Like, woo! It's going to be good.
10:20. Shut up! I didn't really be here.
Hey, Josie, what's one of the forces acting on the cart? Easy answers, easy answers. What's always acting on the cart?
Gravity.
Yeah, which is the force of the what?
Or
Indeed. Force of the earth on the cart. All right. Alex, do you have any other forces acting on your cart besides the earth?
The force of the weight on the cart from that string.
The force of the weight on the cart from the string. Awesome. Thank you for that. That is super true. But we've never talked about forces on strings before, have we? It's kind of exciting, you guys. We'll add it to our inventory later. But you're right. The weight, this stuff down here is pulling on this string, which is pulling on this part of the string, which is pulling on the cart. In which direction is it pulling on the cart? Is it horizontal or vertical?
Horizontal and vertical. It's pulling the cart horizontal.
It's pulling the cart this way, even though this is pulling down. It's weird, you guys, but it's so much fun and it's so great. The force goes in this direction. The force of the rope on the cart. You could also write that as the force of the weight on the cart. That's okay with me too. Yeah, these little things that we're going to hang here, I haven't told you this yet, but are little washers. Okay, like little, they're kind of like construction washers, but these are ones that are made for physics. Anything else acting on the cart?
Surface.
The surface, right? The surface or the track. Which way is that one pulling or pushing, Matt? Up. Up. What kind of a force is that? We've talked about this before. Indeed. So this is a normal force. If you wanted to fill these in, I want to see this on your thing when you turn it in. You've got the normal force, you've got the gravitational force. This one has a fun name. You can call it, I'm going to put it down here. It's a tension force. F sub T for tension. Tension in a string, a taut string. Okay? Now, just for kicks so that we really understand it, talk to me about the net force, the total force in the up and down direction. It's what? It's zero. How do you know it's zero? There's two of them. And you haven't seen this actually in action yet, but you probably can imagine what's going to happen to this cart. Is it going to fly up or fall down? No. So we're just going to write this down because we can. The net force F net in the y direction is equal to 0. We did this on Friday. If the net force is 0, what do you know about the acceleration, friends? It's also 0. What about F net in the x direction?
We got some.
It's not 0 because why? Because you got a tension, and do you have any other forces acting? You have one, and can you have a net force of 0 if you only have one force? No, it's a good thing we asked that question a while ago, right? It is not 0, which means that the acceleration in the x direction is not 0. And your job in this lab is to measure the acceleration of the cart. Okay? We're going to measure the acceleration, and not only are we going to measure, but we're going to find out what different things have an effect on it and how they affect it. Okay? So again, I'll show you the setup in just a minute, but I want to talk to you about how we're going to find acceleration. Because I don't have an accelerometer. Accelerometer is a meter that measures acceleration, right? Accelerometer measures acceleration. I don't have that.
It's hard to think.
I have stopwatches. Beep, beep, beep. Stopwatches measure what?
Time.
Time. So I'm going to measure time. I'm going to release it from rest, which means that the initial velocity is 0. I'm trying to measure the acceleration. So I'm going to put acceleration as my question mark. Bless you. And I'm going to let it go a certain distance. Okay? A displacement. So I'm going to make a D, and I'm going to say that this is something that is constant. So you and your partners are going to figure out what value you want for that constant displacement. So you're going to have a number here, 0 there. You're going to measure time and find acceleration. Really quickly, before we go anywhere, since you already have those equation sheets out in front of you, do you have an equation that you can use here to solve for A? Take a look. Find that equation. Check with your table mate and see if they agree.
I believe we do.
I agree with you.
It's a good one.
I agree with you.
Josie, do you have your shirt on today?
No, you're stolen.
I didn't do anything.
It's the one that you.
Yeah, it's the good one.
But it's that same equation, isn't it? It's the one we love. D equals VIT, right? Plus 1/2 AT squared. We're going to be clever and not cry. We see that that goes away. You might want to write this stuff down so you know it for later, right? And then you've got a constant D. You're measuring T. You can find A, can't you? As a group, you and your partners can rearrange this to solve it for A. Then you'll just be able to plug it in. It'll be easy peasy lemon squeezy. Got it? Okay. I'm going to zoom out. Ooh. Now, different groups are going to do different things. How does blank, and we'll talk about that in a minute, affect the cart's acceleration? So you're going to change something, and then it's going to affect the cart's acceleration. Okay? Once we get over there, I'm just kind of walking you through the process here, friends. You're going to make a plan with your partners. What data do you need? How many values for independent? How many trials? We're going to make smart decisions there. Okay? Who's going to do everything? How are you going to represent data? On the back of this sheet, I left it blank so that you can collect data right there. I want everybody to make a data table. You can have one person do the data table to start, but then everybody's going to turn one in because you're going to turn this yellow sheet and the corresponding blue sheet into me stapled together. That's going to be your lab for this, okay? Does that make sense? Okay. The other page has, you'll notice on the rubric down here, it says that you're going to do this data collection stuff. You made a plan, you're going to do data collection. Oh, there's graph and analysis questions, but I'll give this to you later because I don't want to overwhelm you. Okay? So right now, we're going to go over, I'm going to show you the equipment, and then we will get started.